Okay, everyone, one more video in our section 5.5, permutations and combinations. Let's say 4 people, Alice, Bob, Carlos, and Dorothy, A, B, C, D, are running for an election. And how many ways can the president and the vice president get chosen? So the answer is 12. There's 4 choices for the first spot, the president, and then leaving 3 choices for the second spot, the vice president. Now you could do it this simple way, or you could use a permutation formula. Both lead us to the same answer. Right? Permutations, once again, deal with choosing objects and placing them in order. So the order matters here because president and vice president are completely different positions, and which place that I put the people in does make a difference. If I choose the same 2 people but I place them in different orders, if I assign them different roles, that's a different outcome. Anyway, we could use the permutation formula. N would be 4 and R would be 2. We're choosing 2 people out of 4. We still get 12 there. This looks familiar. This was a class of problems that we've already been dealing with. Let's twist it up a little bit. So in the new part to this video, let's imagine this. What if these same 4 candidates were running for an election to a board of trustees? There's 2 spots available on the board, but they aren't ranked. So there's no president and vice president this time. Our question, in how many ways can these 2 people be selected to fill the positions? So one way to do this problem would be just to list it. Let me get rid of this for a minute. So here's the different list. There are 6 different possible selections. Alice and Bob, Alice and Carlos, Alice and Dorothy, Bob and Carlos, Bob and Dorothy, or Carlos and Dorothy. This problem wasn't so bad, so we could just list out all the possible combinations and count it that way. We would say there are 6 possible combinations of 2 people taken from the 4, because in math, a combination is a selection of a certain number of objects from the total, R objects from N objects, this time without regard to order. So permutation is when an ordering also takes place. Combination is just a selection of a smaller group from a bigger group. Now, we're going to want to come up with a mathematical formula for the combination without having to list out all my options every time. Let's see how that might work. So let's see how we can develop a formula for combinations. So, yeah, once again, how can I get a formula for the number of combinations without having to make a list? Let's notice something. So, notice that even though order didn't matter this time, even though I was calculating a number of commutations and not a permutation, notice that if we permute or we order each combination of 2 candidates, well, there are 2 factorial ways for me to order each combination. So back up here, there are 2 ways for me to order Alice and Bob. I could either order them A and B, or I could order them B and A. There are 2 ways for me to order Alice and Carlos, A and C or C and A, and A and D and D and A, BC and CB, BD and DB, CD and DC. If I take the number of combinations and I figure out how many ways are there for me to place that combination in order, how many ways are there for me to order each combination, then I get a list of permutations. So this is the total number of permutations here. Now I have 12 permutations. I've selected and I've ordered. The big idea that I want us to take away here is that overall we can find the total number of permutations by taking the number of combinations and ordering them, multiplying by the number of ways to order each one. Now, we already have a formula for permutations. We don't have a formula for combinations, but here's how I could figure out that missing formula. So the number of permutations, let's do it for this particular problem. The number of permutations of 12 objects taken 2 objects from 4. The number of permutations is equal to 6, that's the number of combinations, times 2, that's the number of ways to order each combination. And that's 12. That's the same answer that we got before when we were doing this problem with the president and vice president example. Now, in general, what we're saying is the number of permutations is equal to the number of combinations times the number of ways there are for me to order each combination. The number of permutations equals the number of combinations times r factorial. Now, I have a formula for permutations. I don't have a formula for combinations. So what I'm going to do, I'm going to manipulate the pieces in this equation. I'm going to solve this equation for that combination piece, and we get that the number of combinations is equal to the number of permutations divided by r factorial. And I know the formula for number of combinations, so I'm going to plug in the permutation formula. That's the n factorial over n minus r factorial. And here we go. The number of combinations of r objects taken from n objects is given by this formula here. Remember, order doesn't matter with combinations. Let's see this formula in action. Oh, by the way, if we do this formula with n for 4 and r for 2, does it give me 6 like it should? Let's see, so 4 factorial divided by, let's put some in parentheses, so 4 minus 2, that's 2 factorial times, I need another 2 factorial there. Oops. Close my parentheses, and yes, it does give me 6 like it should. Okay. This formula is working for that first problem. Let's see if we can do it for some others. So, how many different 5-card poker hands are there? In other words, how many different ways can I select 5 cards from 52? In this case, order doesn't matter, right? Doesn't matter what order you pick the cards in, just matters what cards you have. So we're going to use the combination formula. In this formula, n is 52. I'm picking from a total of 52 cards. R is 5. I'm picking 5 cards from that total. So I use the formula. I could either do it by hand, work it out the long way. Remember that 52 factorial divided by 47 factorial, a whole bunch of stuff's going to cancel, right? Everything from 47 on down is going to cancel. So the only thing that we're left with is 52 times 51 times 50 times 49 times 48 up on top. And then the 5 factorial in the denominator. That gives me a total of 2,598,960. Now there's a calculator option here too. 52, go over to the probability menu, but this time use the NCR, that stands for combination. Combination of 5 from 52, 2,598,960. Just a way to simplify, speed things up. Okay, let's do a few more examples. Pizzeria makes 5 different toppings. How many different 2-topping pizzas are possible? So we're choosing 2 toppings from the 5. Order doesn't matter. Doesn't matter what order I put the toppings on the pizza. In this case, we get 10. 10 different 2-topping pizzas are possible. By the way, a lot of times we'll shorten this phrasing to 5 choose 2. So instead of, the number of combinations of 2 objects taken from 5 objects, we'll say 5 choose 2 as a shortcut way. Okay, 5 students order different sandwiches and the waiter forgets which sandwich goes with each student. In how many ways can the sandwiches be randomly distributed? So one thing that you're going to have to do for this section, once you get the formulas down or figure out how to do them in your calculator, that's not too bad, but you're going to have to figure out whether to use a permutation formula or a combination formula. And the key difference is whether or not order matters. So in this case, order matters. The order in which the waiter puts the sandwiches down on the table makes the difference. So this is a permutation problem. We're going to use the permutation formula. Now, this is a bit strange. The N and the R are the same. Waiter has 5 sandwiches and he's got to select and order all 5 of them. So we get, the strange part here is that denominator. 5 minus 5, N minus R comes out to be 0. Now in order for 0 factorial can't be 0, because then we'd have division by 0, which is undefined. This whole formula would break down. This is where that definition comes into play. So by definition, 0 factorial is just going to be equal to the number 1. So we end up with 5 factorial divided by 1, 120 different ways for the waiter to put those sandwiches down on the table. Now, later on in this, in the next section, we're going to get into probability. We'll ask questions like, what are the chances that the waiter puts the sandwiches down in the correct order if he just does it randomly? We'll ask those questions later. Another kind of random chance question, Powerball lottery. So in the Powerball lottery, 5 white balls are selected from 69, and then 1 red ball is selected from 26. So we have 69 white balls, numbered 1 through 69, tumbling around in the metal cage. And then in another metal cage, we have 26 red balls labeled 1 through 26. And they choose a winner they choose the winning numbers by picking 5 of the white balls from that big metal cage, and then 1 single red ball from that smaller metal cage. That 1 single red ball is called the Powerball. But the whole thing, how many, kind of confusing, the whole thing's also called the Powerball. How many different Powerball results are there? We mean the entire thing, selecting the white balls and the red balls. So we got to break this problem down into stages. First, we're going to figure out how many different ways there are to choose the white balls. I'm choosing 5 white balls from 69. Order doesn't matter in this case. I tell you that in the problem. But in Powerball, it doesn't matter what order those white balls come out of the cage in. All that matters is whether or not the numbers that you selected match the number of balls that came out of the cage. We're going to use combinations here. But first we figure out how many ways there are for me to choose 5 balls from 69. Then I figure out the number of ways there are for me to pick the red ball. How many ways are there for me to pick 1 red ball from 26? By the way, this just comes down to 26 ways, so it should make sense. But I multiply those two together because I'm doing one followed by the other, one and the other, and we get a total of 292,201,338 different Powerball results. If you get 1 ticket, you have a 1 in 291 million chance. Not very probable. Okay. Almost done here, everybody. A student council needs 4 students. 12 students are running for the seats, and 3 out of those 12 are seniors. Let's do a few parts here. First part, how many different student councils are possible? And then second part B, how many of these have at least 1 senior? So for the first question, that's pretty simple. How many ways are there for me to pick 4 students out of 12? 4 students are going to be on the council, 12 students are running, so we just do 12 choose 4. That gets 496. Second part's a little bit trickier, and it's trickier because of that at least 1 phrasing right here. So at least 1 means 1 or higher. So how many different councils have 1 or more seniors? That means either 1 or 2 or 3, or we could say or 4, but there's not really 4 seniors to even choose from. There's only 3 seniors, so that's not an option. Anyway, this could be done, but it's a little bit complicated. The easier way to do this problem is figure out what how many ways are there for this not to happen? How many different committees don't have at least one senior? In this case, that means how many councils have no seniors, and then we're going to subtract that from the total. So here's how it works. If no students are seniors, then we're not choosing from the 12 anymore, we're only choosing from the 9 non-seniors. So how many councils don't have any seniors on them? 9 choose 4, comes out to 126. If I know that there are 495 councils total, and 126 of those don't have any seniors, then that means that the difference, 495 minus 126 is 369. The difference, that's the number of councils that have at least one senior on them. Okay, we could have answered that a little bit differently, but in some cases, it's easier to calculate the number of ways that something doesn't happen and then subtract that from the total. That's what we did here. One more problem. Let's say we have a package that contains 100 fuses. 10 of them are bad. We pick a sample of 5 fuses from the box and we test them. So how many different samples are possible? Well, how many ways are there for me to pick 5 from 100? 100 choose 5 comes out to a little over 75 million. Actually, not a little over, about 75.25 million. How many different samples contain all good fuses? So this is all the different samples, including, some samples that have some of these bad fuses mixed into them. What if I just wanted to count the number of different samples that only have good fuses in them? Well, if I'm only selecting from the good fuses, then I'm not selecting from a total of 100 anymore. I'm only selecting from 90. 90 choose 5. How many ways are there for me to pick 5 fuses from the 90 good ones in the box? Well, that's less, 43,949,268. Okay. How many samples contain all bad? Well, now we're choosing 5 from only the 10. 10 choose 5 now. How many ways are there for me to choose 5 fuses from 10? 256. Excuse me, 252. Okay. How many samples contain at least one fuse that's bad? Once again, at least one can mean a lot of things. It means one or more. In this type of question, it's easier to figure out how many ways are there for this not to happen. If we don't get at least one bad fuse, that means that they're all good. So here's how many samples have all good fuses. Here's the total. If I take the samples that have all good fuses away from the total, that will tell me the samples that have at least one bad fuse. In this case, that comes out to over 31 million. Finally, let's see. How many samples contain 2 bad fuses and 3 good ones? Let's break this down into a couple different tasks. First, let's figure out how many ways there are for me to pick the bad fuses. Then let me figure out how many ways are there for me to pick the good fuses. And finally, I'm going to multiply, because using that multiplication principle. So, how many ways are there for me to pick 2 bad fuses? Well, there are 10 bad fuses. There are 10 bad fuses in the box. How many ways are there for me to pick 2 from that 10? That's a combination. 10 choose 2 comes out to 45. Then, how many ways are there for me to pick 3 good fuses? There are 90 good fuses in the box. 90 choose 3 comes out to 117,480. Finally, my package of 5 fuses contains, if I want my package of 5 fuses to contain both 2 bad and 3 good, then I'm going to multiply these two together and get 5.25 million-ish, 5,286,600. So if our problem can be broken down into many tasks, then we can figure out how many ways there are there for me to do each task individually and multiply them together. We're using that multiplication principle. I said that was the last one, but let's do one more. Why not? Okay, a committee has 4 male and 5 female members. In how many ways can a subcommittee of 2 males and 2 females be selected? This is very similar to the last problem. First, we're going to figure out how many ways are there for me to pick the males. 4 choose 2. There are 4 males. I'm choosing 2. How many ways are there for me to pick the females? 5 choose 2. There's 5 females, and I'm choosing 2. And so that works out to a total of 6 times 10 is 60. Okay, that's where we're going to stop, everybody. Let me know if you have any questions. Good luck on that homework, and I'll see you later.